Hey folks, since in the previous session we have touched upon how to define a dictionary so that we will pass this dictionary just to our cross-validation algorithms. That's what we have touched upon in the previous session. So in this session what we have to do is we have to just apply this algorithm often known as randomized search CV and grid search CV. So first and foremost, let's touch upon how to implement it using randomized search CV. So first and foremost, we need to import where exactly is my randomized search CV. So what I will do is I will say, hey, from scikit-learn, can you go inside of some module often known as model underscore selection? Oh, my bad. It is exactly from. Sounds good. The moment I press tab, this is exactly some module. Let me go inside this CV algorithm. Let me execute this line of code. So if I will say, hey, can you initialize this CV algorithm? The moment I press shift plus tab, it says first and foremost, you need to pass the estimator or the object of the machine learning algorithm. Then you have to pass your parameter distribution, which is all about this random grid. Then we have the number of iterations done. Again, for those of you who have good specifications, PC, laptop, you can think of customizing this number of iteration parameter to up to some greater extent, let's say 20, let's say 30 or 40. Then we have some scoring metric. Then we have number of jobs. Again, if it is -1, it means it is using all the cores of your CPU. Then we have verbose. The verbose values is typically defined just to read all the execution step. Similarly, we have a lot of other parameter. Again, you can just go to below and you can have an eye on all the parameters. That's not rocket science. It says, hey, number of jobs. Let's see number of job. When it is -1, it means it is using all the processor. Similarly, let me show you some of the parameter. Number of iteration. It means number of parameter settings that you can sampled. That's what it says. Similarly, param underscore distribution, one of the most important parameter. Here we have to mention data in the form of dictionary or a list of dictionary. What we have defined. So what I will do is I will say, hey, my estimator, which is all about nothing but my RF, because RF is typically, it is nothing but a object of the random forest classifier. So I will say it is all about RF. Similarly, param underscore distribution is all about random grid. So it is exactly random grid. Sounds good. Again, similarly, if you want to customize this n underscore iteration, it's all up to you. Similarly, we have something known as n underscore jobs. Similarly, we have something known as verbose. Let's say verbose equals to, let's say 1. Similarly, let's say n underscore jobs equals to, let's say -1. Let me cross check what can be the possible values of your verbose parameter. Let me scroll it to below. Let me cross check that. So I will say scoring and jobs, pre-dispatch, CV parameter, one of the most important parameter. Verbose, it can be the value of your integer. Sounds good. The higher, the more messages. It typically means the more the value, the more messages you will get across the output cell. Similarly, we have CV parameter. Again, by default it is 5. If you want to customize it, you can say 3, 4, 10, whatever else. Let's say 3. Let me store it in, let's say random. Let me execute this line of code. Using this random, I have to say, hey, can I fit my data? I have to just fit all the data of my X train. Then I will say y underscore train. Now the moment I will execute this line of code, again, it will take more time depending upon all your system specifications. Once this cell will get executed, using this random object, you have to just call a predict function on top of your x underscore test. That's it. You will end up getting all the predictions over here. That's what actually my randomized search CV stands for. Similarly, if I will say with respect to, let's say, grid search. So what I will do is I will say, let's try to comment it out and let's try to provide a accurate heading. So I will say it is all about nothing but a grid search. Let me make it as markdown. Let me execute. Sounds good. And if I will say this time, it is nothing but, let's say, parameter grid or parameter grid, whatever else, it's all up to you. And the moment I will execute it, and if I will say, hey, can I print my something known as parameter grid? Let me execute. Now this is a dictionary that you have. Again, let's say you have this dictionary. So you might expect a question in your interview that, hey, can you tell what can be the possible iteration? What can be the possible iteration if you have such dictionary in your grid search CV? Again, as we know, grid search typically works on the basis of permutation and combinations. So we can say as school, these values are 5. We will say 5 into nothing but 3, into nothing but 5, into nothing but 4, into nothing but 5, into nothing but 2. Whatever summation it will give, these are exactly the total number of the iterations that we have. In general, this is basically 3000. It means if I have such dictionary, my total iterations in my grid search is typically 3000. That's how you can compute it actually. Sounds good. Now let's try to implement your grid search CV. So I will say from this scikit-learn module, I will say from scikit-learn dot, if I'm not wrong, it is model underscore selection. Let me cross check that. Let me press tab over there. Yeah, this is that. From this, I have to go inside something known as grid search CV. Let me press tab. This is exactly that algorithm. Now using this grid search CV, first and foremost, I need to create its object, or first and foremost, I need to initialize it. Again, it is quite simple. It is pretty much similar to the randomized search CV. The basic difference is that randomized search CV typically consider the pair in a random way, but this grid search CV uses permutation and combination just to pick a pair. So over here, I will say estimate is all about my random forest. Similarly, my param distribution is all about my param grid. And if I want to customize some more stuff, I will say CV equals to 2. Similarly, and jobs, let's say -1. Similarly, let's say verbose equals to 2. Let me store it in, let's say grid. Let me execute. Using this grid, I have to say, hey, can I call a fit, or can I fit my training data to this grid? So I will say xtrain and ytrain. The moment I will execute this line of code, it will take a couple of minutes. Then you can think of calling a predict function using this grid on top of our x_test data, and you will get up all the predictions that you have. That's how thing actually works under the hood. So similarly, in a similar way, let's say with respect to random forest, we have such a dictionary. Let's say I have to hypertune my logistic regression. So I can say, hey, I have some other interesting parameter. I have a very important parameter which is all about a C. Similarly, we have a penalty parameter. It means what regularization you have to use. Again, in general, C is nothing but an inverse of lambda. Similarly, we have a penalty parameter. Again, we have a lot of parameter inside in this logistic regression, but these are some of the most frequent used parameters even in context of real world. So for those of you who have any doubt, feel free to utilize the Q&A as much as you can. So that's all about this session. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.